So here is another problem where one of the equations is nonlinear and one is linear. So the substitution method, of course, is more suitable. And so we transpose one of the variables and substitute it into the other equation. Now, it will be a wise choice to substitute the linear one. Far easier. We can substitute for either the x or the y. Well, let me transpose for the y. Alright? Bring over the x there. This equation will become y equal to 3 minus x. Alright? I'll just group the x here with this 3. So y equal to 3 minus x, so we can substitute y equal 3 minus x into equation 1. And here's equation 1, x squared. I must write back equation 1 in full. X squared plus 2xy is equal to 5. So we're replacing the y with 3 minus x. So 2x. And we're replacing the y now with 3 minus x. And of course we expand the bracket. So we'll have x squared plus, expand means to multiply each term in the bracket by 2x, whatever is outside. In this case 2x is outside. So 2x times 3, that's 6x. And 2x times minus x, that's minus 2x squared, equal to 5. And here we can group. So this is 1x squared. Don't forget x squared is 1x squared. So we have 1x squared minus 2x squared. That's minus 1x squared. And we have positive 6x. And we have, well, equal to 5. We observe maybe the best thing to do is maybe group on the other side so that the coefficient for the x squared is positive, since we plan to factorize. So if I bring over these, I'll have 0. And if this negative 1x squared will become positive 1x squared. And this positive 6x, negative 6x, since I'm taking everything on the other side, and then 5 remains 5. As it already was on the right hand side. So we can solve by factorizing. We just factorize the quadratic. And to factorize the quadratic, we need to rewrite the minus 6, and the two numbers, of course, must multiply to give 5. But 5 is a prime number, and prime number only have two factors, right? One on itself. So we can break up the minus 6x as minus 1x, minus 5x. Or you could switch the order, it doesn't matter, and then you have a positive 5. So I rewrite the minus 6 as minus 1 minus 5. And then I factor by groups. So for the first group here, common factor here is x. So I factor out x. I'm left with x minus 1. For the other group, I factor out minus 5. And then I will left with x minus 1. Now we know we should get the same bracket, right? So 0 is equal to the common bracket x minus 1, and outside we have x minus 5. And also to solve this quadratic equation, you could have used a quadratic formula if you wish. A is 1, b is minus 6, c is 5. Or you could use the completing the square method. And all of these videos or on the channel, so please like and subscribe. Search for those videos and you will find them easily. So we equate both brackets to 0 after we factorize. We equate both brackets to 0. So we equate x minus 1 to 0. Also, the other bracket, x minus 5, is 0. And again, the rational, if this bracket times this bracket multiply to give 0, then one of them has to be 0. Alright? So x equal to 1 is the solution for this. And x equal to 5 is the solution for the other. And we sub each of these x values into one of the equations. Let's use the y equation. So here it says y equal 3 minus 5x. So here, since y is equal to 3 minus 5x, 3 minus x, sorry, y equal to 3 minus x. So this is 3 minus x, and we know x is 1, right? So hence, in this case, y is 2. Here, again, we have y equal 3 minus x. So instead of x, we know the x as 5, right? In this case, so y equal to 3 minus 5, which is minus 2. So the solution, so these two graphs, if you should plot these two graphs, sketch them, they will intersect. When x is 1, the y is 2. And also when x is 5, y is minus 2. So they will intersect at the point 1, 2, and at the point 5, negative 2. That's our solution.